Testing. Testing. Can you guys hear me? Testing. Testing. Can you hear me? Testing. 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 Are you guys in the chat? You guys, if you guys are in. There's a huge latency on YouTube stream. Yeah. I'm just gonna stream on Discord, then record on YouTube. Okay. Not yet. Yeah, it's a subscription. No, I cannot do. I wish I can do, but the stream lag is too much. Okay, I'm not so sure if everyone's in yet. There's only 10 people. Everyone else can solve. Huh? Yeah, I can just start. Oh, it's already 10 already. Alright. Today's class is 10, it's smaller. Okay. Can you hear me, right? Yeah. Okay, good. Very good. Ah shit, I'm not sure whether your voice will be heard through the YouTube video, but it's fine. We'll live and learn. Okay, so for today, for this lab, okay, let's not use the word. For today, we are doing array class template. Yeah, we're doing a class template for array. So when it comes to an array, right, we know that to initialize array is usually what you do is you do array, then int, and then something like that. So int is the data type, and then is the size of the array. So building from this knowledge, we just build a class template t, type name t. This is our type, and in size tn, this will be our size of the array. Okay. So there's many ways to build a template class, but we've been doing it this way. So because I think this way is much more easier to implement. So for our class, what we need to do now is create our small little type def macros. Okay. So for C++, you can use type def, and then you can define the type macros, but we will be using keyword. So for the first one, let's say our size type will equals to size t. So what this means, right? This will be our array size type, class size type, that we'll be using throughout. So we don't have. So if we want to change our class size type, we can just change this value here, and then we don't have to go through each single function to figure out what we need to change. Right, so it's very useful to use using. So now since we got size type, we will need our value type. So value type will be t, right? Because our array type is t, so value type is just t. So this is our class data type, right? And now since we got our class data type already, let's create a pointer, which is just value type star, and then we make a const pointer, then we'll use a reference and reference, right, %, and then we'll const reference, right? So we've done all this. This will be what we will use throughout. Very useful. So if you want to change stuff, right, you just change these two, and then they will all follow. Okay. So now we are still in the class domain. So we're not looking at the template. Not much on the template yet, except for this t. Okay. So for array constructors. For class constructors, we know there is the default constructor, there is the parameter, the initialize constructor, there is the initializer list constructor, there's a copy constructor, and there's a copy assignment constructor. So what will a copy assignment constructor? Okay, so there are basically five constructors that you can use to construct a class, but for now we'll be following the rule of 3 and only create 3 constructors, right? So we have our default constructor array, we will have our initializer list, okay, initializer list, this is switch, alright, and then we will have our copy constructor. So this will be array, reference, const reference, RHS. Right, you don't need to put this. I'll just put it so that it's just easier for you guys to understand. So what we've done so far, right, is that we have created 3 constructors. So let's see whether we made any mistake. So just make, okay, not make. Let's just compile our array. HPP. Okay, it seems like we have some errors here. Oh, okay. This is because we still have this. Let me just comment this out. Okay, got some errors here. Right, forget the semicolon. Common mistake. The initializer list. Did we include? Yes, we did include. Maybe I spelled it wrongly. You just copy this. Okay, so we are successful in creating our 3 constructors. Now, constructor, very simple. Just array. Right. And then, okay, now that we created our constructor and destructor, for this exercise, we will not be, how to say, using this. We will not be doing much with this, because we are not. It's a static array. It's not a dynamic array, so we definitely have nothing to do here. And for this one, right, we will have a shortcut to show you how to initialize a default array. So for now, instead of using this, since we are not going to define this default and not going to define a default constructor, we're just going to tell the compiler that we just use the default stuff. right? This is not, so we're just telling the compiler that I'm not going to do anything. I just want to put it there just for show. Right? So now I'll copy assignment. Very easy. So for copy, so in case you guys still don't know how to make class, for copy assignment, what we expect the behavior to be, right, is we are using this operator equals, and we're going to assign it to we're going to copy from another class. So we're going to copy from an array const. We're going to copy array from array const. Let's do this. And then once we copy, we're going to return it into an array, right? So we give back array reference, and then that's it. Okay, so that's how you create a class function, in case you guys still not so sure. So this is operator overload, this is the parameter, and this is the return type. So since we should expect the client to also use initializer list to copy it and copy the data of array. So what we will do here, right, is, okay, we know that we're going to return an array. Okay, we know that we're using this, but the parameter now will be this. This will be the parameter. So we are overloading our operator overload. Right. So you can either take an array, a const array, or std, a const reference to an array, or std treasure list. So either copy the same object or copy a list. Right, now for our accessor. For our accessors, as we have used arrays before, you know that to access an array, we need a square bracket, right? And then what we're going to put inside the square bracket, the parameter. So the parameter that we're going to put inside this, the index that we're going to put inside the square bracket will be the parameter. Sorry. So it will just be t, right? Oh no, we shouldn't use t. We should use value type, and then we just put index. Yeah, we just do this, and then what we're going to return, value type. Reference. Yep. Actually, do we need? Yeah, it's fine. Right. So what it does here is you put an array inside. Here. Let's say you want to call an array. Then you say, oh, I want to call the first digit. So you will take this index. This will be the index inside the square bracket operator, and then you look through the index. You should return the. We do something. You have to define what it's gonna do. But this is how it's being called. Right. So for this one, we will assume that there might be const array. So we're just gonna do this, right? In case the function that calls this array will have, the array might be const. Then to maintain the constness, we just put a const here. Alright, so let's check so far whether everything is properly. Yep. Okay, so we're done with accessor, done copy assignment, instructor, and constructor. Now let's move on to member functions. Right. So for member functions, we're not done with accessors yet. What we have done so far, right, is that we have give them back. We are able to give back the index, right? But we have not. We should also give them just like an easy way for the clients or the programmers that use this, right? We can give them the first value, the first value, right? Well, the first value can be first value will be determined by this, a front function, and then we're going to return them a value type reference. So since you see this, right, value type reference, it's a bit annoying to type, and then so we can just copy this since we already declared the type def here. Just copy this here, type reference, value type reference, and then since this is const, we should have a const reference, right? Const reference, easy. Then we'll do another reference, const reference. Let me just copy this, paste, copy, paste. Right, so now we have front, and then let's do the last one. So now we will do the last element. The last element will be the element in the back, so we call the function back, and then we just copy this and paste. Oh, the reference looks a bit sus. Yeah. Okay, so our accessors and everything is, oops, seems to be an error, cannot be overloaded. Is it because, yes, it's because I didn't put const. So yeah, it says that, oh right, const and const, and then now it should be different functions. Yep, previously it was because it looks like they were the same function, because remember with function overloading, right, you don't look at the return type, you only look at the signature, which is the name of the function, the parameters and the number of parameters. So since it was like this, to the compiler they look the same, right? But then they are given, and they are given a different return type. So the compiler understands that you're trying to overload it, but you can't do it like in this way. So yeah, you cannot overload. Doesn't make sense to the compiler, so that's why it's complaining here. But now it should be fine already. Right, okay, so now for let's skip the member function first. Let's do our iterators, because these are more crucial, more aligned to the array, a class, right? So same thing as we did for vectors. We just have a pointer that points to the beginning, and then we'll have the const pointer. For vector we did const pointer, right? But this time we're gonna do const iterator. It's the same thing. It's just that the driver for this session or this lab uses, hang on, my cat has climbed up to the table. Hey, go down. Alright, sorry for interruption. So and then we're gonna do, we're not done now. Const iterator in const, we still need a const iterator to a const array. Yeah, don't know why it's okay. Yeah, so this is just to, in case you guys still don't understand what we're doing here. This is a normal pointer, this is a const pointer, and this is a const pointer to a const array or const object. Alright, so now that we have done this, let's do it for n. So shortcut, just highlight this, you press Ctrl hit, and you just replace. And oh, looks like there's an error here. And then, yep. Yeah, easy stuff. So now we are done with this. Let's move on to our member functions. So for this time round, the unit test will only test simple stuff like fill. So for void fill, what void fill does, right? it will fill up the elements of the array with just one value, right? So for the value that we're going to fill up, we're just going to say, we can say t const value, but for this case it doesn't really need a reference. There's no advantage of using reference, but I don't know, it doesn't matter what you do. And then for swap, we are swapping into arrays, so we will take an array input, and we don't want it to be const reference because we're going to swap them. And then for next one, it's an empty, so you're going to check whether that array will be empty or not, and then it's const. And then for the last one, it's our size type. So no, not our size type, we're going to return our size of the array, right? Because they'll be interested to know whether it's empty, and how much elements are there inside. And for these two, they're just functions so that they can manipulate the array. Okay, all these are done. Now remember when we construct the class array template, we did type name t and size type n, right? And then remember that we did not declare an array default constructor. And we're going to tell you why we set it to default, because we are going to do it here, right? So t data, this will be our data member, and then n, so this is the type of our array, and our n will be our size t n, right? So in this case will be array in 10. So 10 will be the amount of elements inside the array. So it's kind of cheating that we're using array to construct an array, but our advantage here is that we are able to construct different data types, different array data types, like string, char, or int, right? And then this is our default constructor right over here. Alright, so whenever we call a new array, it's just going to construct empty values based on how much data, how much size we give it to, and all the data will be initialized with t. It will be initialized with data type of t, but it will be empty. It will be 0. Right? Oh shit! What's this? Oh right, because I name it as const pointer. Alright. Yep. Okay, so now we are done with our array HPP. We'll introduce a new type of file called array TPP. As far as the comments dot say, all the definitions for member functions will be declared in the class template array TPP, and we will go through creating some of it. So array.tpp. If you are curious to know how to open that thing, right, it's just Ctrl E, and then you just open this. Alright, so most of the functions here I have already declared, so it's not fun. What I'm gonna do, right, is I'm gonna clear all this. Right, all this I'm just, except for the last one. The last one is quite simple. Okay, all this return reference, return thing, size empty, swap, fill, I'll just clear. Alright. You know what? I'm just gonna clear it. Okay. So let's look at the driver. So array driver. Okay. So this is our driver. No need to know about it. So we'll just I'm not so sure how you guys test. I'm just gonna assume that you guys don't know how to test, because from what I've seen, you guys don't know how to test. So there are three main test functions that the driver will test. The unit, here's a unit test. So let's isolate. Okay, the easiest one will be in. So let's just do in. Alright. So let's comment this stuff out. Now the array size is 1. These are automatically. And then let's comment. Yep, we don't need this. and we don't need this. And then let's try to make, see whether there's any error. Yep, okay, all this error, right? It's just undefined reference because we haven't defined all the stuff yet. Alright. And then so now we only are doing int. Let's open up our int, and we'll be right here. Okay, let me just close this so there's more space. Okay, so for our int, let's isolate the test inside as well. So we will do only a few tests. Great. Okay. So for now, our first test will be to default construct using an initializer list. Easy enough. Let's start doing it. Okay. So let's look at HPP. Let's see how we define it. We define it as array std blah blah blah. So let's just copy it over here. But remember, it's a template, and our class template is right here. Well, let's use the class template, and then let's open it up. Okay, so as from previous classes implementation, what you guys have done is that you guys have looked at the data members, you copy it out, you put it here, and you initialize it. But we really initialize it over here, right? We really construct, so we don't have to do this, not necessary anymore. But what we do need to do, right, is to put all this data of the initializer list into this array object A that we're going to construct. Alright, so for this one, what we're going to do is that since we have a data array that points to the first element, right? This one points to the first element. We should not manipulate it. Instead, we should create a temp pointer that help us with it. Alright? So inside this, we will do a range for loop to loop through all the data in RHS, which is this. We'll loop through each data starting from here, and we'll go through all of it and store it into data, which is now temp. Alright, we're going to move temp, we won't move data, so that our array won't get corrupted. So let's do for each loop we will need a value. We need to declare what's inside the element for each loop, what element type and what's the variable name, and then the loop that we're going to loop through will be, the container we're going to loop through is the RHS, the initializer list. So for each value in RHS, what are we going to do? We are going to store it into temp equals to path, right? And then this. So we're going to store it into temp, and then we're going to increment each loop. Right? Makes sense? And then that's it. Let's run the code, see whether it works. Quick. Alright, what's the error? Oh, right, because must have trailing return type. Alright, one thing we forgot to do. Did we include? Oh yeah. Okay, one thing we forget to do, right, is we forget to include the scope. Right, because right now this array doesn't know where it belongs, which scope it is. Actually, it does. It kind of knows. Deduction guide for array must actually return type. So it knows. No, it doesn't know. So we must put the scope. Right? Let's put the scope for it. So if we put the scope, since our array is constructed with array t size n, array t n, yeah. So let's put array t n, and then scope it, and then let's see whether it works. Yep, it works. And then now to print the stuff, we need begin and end. Well, let's do that. I kind of regret deleting it, but then I hope you guys are doing it with me. You can make mistakes and you can learn at the same time. So for begin, copy the thing on top, and then we are going to copy this as well. Should we copy all of it? No, just copy one. Just don't get ahead of yourself and copy everything, because once you make one mistake, right, it's gonna be hard to troubleshoot for everything. You're just gonna get a long list of message on your console, and that's not very helpful to identify the bug. Let's copy begin. Okay, same thing as previously. We need to scope our function, right? And now this pointer, right, for a class template, they're not sure what you're referring to when you say pointer, because this is not a standard, standard data. This is a user defined data type. So for user defined data types for class templates, right, first you need to tell it where it comes from. Oops. And then you're going to tell it like, oh, this is user defined. Understand that? Nothing much to explain, but just like that. And then for our begin function, it can just be one line, right? Just going to return data, and then that's it. And then we can do the same for the rest. Let's just do all this. Alright, copy, paste, coins pointer, and cons. Right, cons, because that's how the function is. Cons is to make sure that we promise the client the client that we're not going to change their data. And then we are going to make for cons array. Alright, now we're done with that. Let's do n. Right, I'm going to do the replace again. So for n, what different about n is that you're returning the, how to say, so this is the pointer to the start, but now you're going to point to the end. How do you determine the end of an array? The end of the array is the, how to say, the full length of the array will, the end of the array is at the end of the array, right? So to get the end of the array, you just it with n, the size, and then we will go to the array's end, right? Because anything more than the size is the end. Makes sense, right? I thought I'd draw this out. I think you guys are quite familiar with how it should be done. Okay, so as long as the begin and end, we should be able to get some inputs. I mean some, how to say, we still got some undefined reference. Undefined reference to begin. Is it because I didn't save? What is the error? Let's read it. Undefined reference to end and begin, even though they are both here. So is it that he couldn't see? Type name. Let's try to run. Let's try to compile array by itself. There's some error here. No declaration matches type name HPP to array. Oh, I put coins pointer here. Oh, okay. Coins iterator. I got ahead of myself. Oh, still got some error. That's with int. Undefined reference to int end. It's right here. Can't you see it? Undefined reference to n. Data plus n. Tn pointer array tn n. Array is not a template. Array is not a template. Something is wrong. Array should be a template. Okay, problem seems to be around here. Let's check. Yeah, it's in the same folder. I did include it. Oops. What's the problem here? Undefined reference to pointer, no, to n, just to n. Doesn't see this. Did I do something wrong? Pointer n. Right, pointer n. Let's try this. What if I put it here? Redefinition of an array TPP. So they see it. What? Okay. Seems to work now. Yeah. I guess I didn't save just now. So that's why there was no. Alright, so we got output out. Let me show you what happens if you don't do this. If you just do this. See how corrupted our data becomes. Yeah. So even though they even prevent you from doing it. Yeah. So it's fine. Compiler protect you. Okay. Never mind. No worries. So for now, we're done with the first test. Actually, we're done with 3 tests. Constructor and begin and end. So let's do this one. Fill. Right, first one. Let's hope there's no problems. Okay, for fill, what fill does, it fills the stuff. Right? Make sense? Fill fills. Right? And doesn't have return. So we go to fill an array. So first, scope it, and then what we're gonna do? C star array. So this will be how we're going to look through the array, and then for actually we just copy this. Right? Actually we need this. Wait, this is fill, so we don't need this. We just need to go through the data. So for okay, yeah, we don't need this. We can just do another type of star array, which is a while array. So for a while, how to say? No, we still need this. Temp data. So while temp tmp does not equals to n, then tmp plus plus equals to valve. Make sense? Yeah, easy. So what we've done is that we've filled everything. Let's check the output. Okay, don't take my word for it. Let me just check the output. Test int. Yes. Okay, so the first one, 1357, correct. A999, correct. Good. Okay, what's next? Test fill. again. Oh, test operator index. Oh, test operator. This is our accessor. Bracket operator. Alright. Copy this again. And then with our bracket operator, there's 2. Just copy 1 in case something goes wrong with the first one. Okay. So same as here. Scope this and scope this. Right. And then we're going to the data index, and then we're going to do the cons version as well. Operator cons, and then cons reference, and then cons got some error. Oh, we don't put cons here. That's a dumb thing to do. What did I do? That's not how you spell cons as well. Oh no, everything is falling apart. Cons. Remove this. Put it here. Yeah. Alright. Works. Does it work? Is it legit? It is legit. Alright, what's next? Swap. So very simple. Alright. Already, and what am I supposed to do? Oh, don't do this. Don't do what I did. This is wrong. Let's copy this. And then let's take our swap. Our swap is right over here. Let's copy that. So this is void. We return nothing. Let's scope it out. Scope it with the array template class template. And then now we're gonna swap. So easy. We're gonna make a pointer that points to temp RHS. Right? Then data. What's a pointer? Data pointer. Data begin. No. Yes. No. Okay. Swap. I don't know whether you guys know about this, but I can teach you easily. Very fast game. So for the swap array, right, there's the copy swap idiom, right, that we should all know, that we've been doing blindly, but we don't know what it actually means. So I'm going to introduce it to you. Country plot idiom. I didn't spell idiom properly. I don't know how to spell properly, but let me just quick search how to spell idiom. Only an idiot cannot spell idiom. Idioms. Okay. So what we are doing now is we're doing the copy swap idiom. Right? So idiom is just a term for programming, and then we're going to copy swap. So about copy swap, right? The copy is when you copy it to a temp, right? Temp equals to, let's say we want to swap left into right and right into left. So temp will equals to left, and then we just do this. Left will equals to right, then right, oops, right will equals to temp. See? So this is a copy swap idiom. On the, you just follow like this. Arrows, follow the arrows. Temp, left, right, temp. Okay? Just remember this idiom. Very important, very crucial, very essential, fundamental in programming. Okay, so let's do it here. Pointer temp RHS. So now our temp has our, what do you call it? Starting point, like it has copied it. So now we start the swap. So for swap RHS dot will equals, okay, we can't do this equals to data. RHS dot data. You cannot equals an array. Doesn't make sense. Oh, okay, never mind. Ignore this one first. Let me just, okay. We cannot do this, okay? Array assignment, you don't just equals like that. It does not make sense. Oh, you guys hasn't been able to see the whole thing. Wait, let me fix it really quickly. You guys haven't been able to see this. Okay. So, like what I just said, you cannot just copy an array to an array. I mean, assign an array to an array. It's invalid. What we need to do, right, is that we're going to assign the pointer to the pointer. So this is return data pointer. We can return pointer to point. We can just swap the pointers. It is fine. Or we can swap every data inside, which is also valid. But what we're going to do is just going to swap the pointers. So RHS will equals to this. So this is the function that's on the left hand side. This will be this, right? This will be this, because this is how to say, the member function comes out from this A, doesn't come from B. That's why this is the left hand side and this is the right hand side. Okay, so RHS equals to this, and then since you already copied the thing, you just do this equals to temp. So since we're not doing pointer, we're just copying array, we can just do array temp equals to RHS, right? And then now there's going to be a new problem, because we don't have this operator. So let's do it. Copy assignment. Copy assignment operator. Let's do it here. Paste this one first, and I'll paste this, and then I'll scope this, and then I'll copy. So for copy assignment, just going to what we're going to do is that, okay, what we're going to do now for copy assignment is that we're gonna copy all the data in one pointer to another, from one array object to another array object, and as usual, C-style array, we're going to treat it as a C-style array. So pointer temp, then initialize data, and then for each value in RHS, in RHS, we are going to we're going to assign it to temp, right? And then we will return studies. Okay, so operator done, super fast. And then there's going to be an error here. Let's see what the error is. Oh, and save. Oh, there's a no. Save. Yeah, okay, error came out. Okay, what's the error? Okay, what's the error? Alright, so the error here is that the return type, right, doesn't make sense to the array, because you're returning an array, you're not returning a class template array. you're returning a class of array. So in order to tell a compiler that you're doing a class template, just do this and you're fine. Okay, so let's do the const version. Const version will be, oh no, not const version. Okay, const version. Do we need a const version? We don't need a const version. No, we don't need a const version. So what's the error here? I didn't save. Let's save it. Operator undefined reference to HLP2 array intil const end. What is this? Oh, let's look at this. I think what it's trying to say, right, is that we didn't define this array here, array, then HLP2 const reference. Yeah, so we didn't define this. So let's define it so that it's happy under this. Yes, that's a good place. Okay. We didn't. Yeah, I thought we did because I saw this. Alright, we didn't. Then copy this again. So for constructors, right, there's no return type, so we don't have. So that's why we didn't do this. It's just construct, so you're not returning anything. Alright, and then we need to scope it. Oops. Okay, for this copy constructor, because we did this, that's why we need a copy constructor. For this copy constructor, what we can do is very simple. It's actually the same thing. Same thing as this. See, this is really easy, barely an inconvenience. And, oh, save. Oh, what's the error now? Oh yeah, we don't need this anymore. This is double declaration. Then it says here redefinition, then it shows you where it previously declared. Okay, learn how to read the compiler. And then now we're done. Yep, and we got this. And then we got this. Right, perfect. We build it. So let's go through how it runs again. A.swap b. So when you swap the function, you will assign it to a temporary array. So the temporary array will, this temporary array will be equals to RHS. So in order to run this function, right, we need the equals operator. So when you use the equals operator, I initialize the temper. I initialize another copy pointer, right? So when you initialize this, you also have to initialize the copy constructor. This copy constructor, to construct it is similar as to construct a initializer list, because they both contain data. They both store data in the same manner. And then for equals operator, same thing. Just that you just need to return this, because it's not a constructor anymore, it's a function, and it needs to return the array so that the people that use the function will know where this is. Like, so now we know that this belongs to them, right? And then now we have temp equals to RHS, copy swap idiom. Let me just show you again, so you guys really absorb it, right? So copy swap idiom, temp equals to left. Oh, we put left, but here is right. And then right will equals to left, then left will equals to temp. Then you remember your constructor, how it works. Since this is constructed, since temp array is constructed within this scope, once we are out of scope, right, this is automatically destroyed. Okay, then we don't have to worry about it anymore. Right? Thanks to the C++ compiler. Your friend and your enemy. your best friend and your worst enemy. Alright, next we're going to test empty, size, front and back. Very weird way to when you say it all together. Alright, so we have, let's see what we're missing. We are missing empty, front, back and size. Okay, so let's do it. Do it. Empty is here. It's under swap. Yes. Okay. Copy this here. Copy this here. Shift tab. Oops, that's the wrong shift tab. Shift tab. Alright. So boolean empty cons. Let's copy it. And the reason why it's cons is because why will you be changing the thing? Just cons. You're just going to check whether it's empty or not. So how do you go to check whether it's empty? This type of stuff, quite basic. In case, but I'm going to assume that you guys don't know. So you're just going to check. You're going to use a ternary operator, right? We're going to check if size equals to 0. If size equals to 0, that's how you know it's empty, right? So let's make it. So that's a pseudocode. Let's make it work. So let's make it work. Is size this? Is this? There's a invincible this here. This is why you don't need this, because it assumes that you are calling the member function of that object. Alright. So size equals to 0. Then we're gonna do. The most of you will do this. If size equals to 0, return true, else return false. Right. But this is only 2 return cases and it's very simple. So why not? Let's save everyone's time and just do. What if we do a ternary operator and we do this, right? Right, but this is not how you should. This is not how you should declare a return ternary operator. It needs an L value. Return needs to be an L. Return cannot be inside this thing, right? I'll show you the error. What it looks like. Never save. Okay, what it looks like. Yeah, so you expect a primary expression before return, after return, before return. It doesn't make sense because return should be the first thing. And then you need either this or this. It doesn't know, it doesn't assume. So it just tells you that something goes wrong. So just do the right way. Okay? Return true false. Ternary operator. And it works. Okay, so that's how you compile one by one. Don't do all the functions and then compile afterwards. Compile each function by line. Okay, I've seen people that did all at once and then you're just having a bad time. Just asking for a bad time. What we're missing now is undefined reference to size cons. And then let's do it. Should be easy. We got template here. Let's use it. And then since we are returning a user defined type name that is defined in class in array template in the class template array, we just need to scope it. And then as usual we scope our functions as well. And then we're just going to return size. So how do you return size? You return size. Make sense? No, wait, that's not the right way to do it. You return n, right? Because n is the size that we declared over here, right? Size of array n. So just return n. Oh shit! What did I close? Okay, disaster averted. right? So these are very simple stuff. We can make it one line, so the code is more clean. Clean code, okay? Very crucial. If your code is not clean, if I see people, I mean, okay, this is opinion, but I don't like it when it's like that. You waste line. Okay, make your code clean. Okay, clean as possible. Alright, next, what we're missing now is, oops, I did something wrong. Still. What we're missing now is back and front. We're missing our back and front. So our back and front belongs over here, where the accessors are. Let's copy this here, and then let's copy this, and then let's copy. Copying is fun. Says no one ever. And back name. Okay, front. What it is? How do we return the first element? How to return the first element of the array? You return the first element of the array. Right. So for our front, since we have all this over here, size begin, all those, we can use this, but then we can use this your return data, and then we can just use this straight away, and then we'll return, since we want the element inside, we'll dereference it, right? And then we should get our value out. Right, good. Let's make the cons version. It's just cons reference, and then let's make sure that it's clean, and then let's do our back. Let's just copy. Let's not copy that. Wait. Okay, let's do our back. Back. How to do back? That's it. That's it. No need to think so hard. Copy this. Copy this. Cons. Then cons reference. Oops. Right. Clean. And then save. Oh, that name array. Okay. Oh, stack smashing detected. So what stack smashing means, like, it means that you have tried to access a memory that was not initialized in not really say not initialized, but you have tried to access an array that was not assigned to the program, to the executable. So let's say if you are creating an array, let's move down. Okay, so int 10, right? Int 10. We have created an array of 10, right? Times 10. So what this means, right? You created an array of 10, is that the CPU or whatever has given you this address, right? This is given to you because you requested for you is given. You ask and you shall receive, and then you receive 10 blocks of memory. 10 blocks of memory. So what happens in stack smashing, right, is that you have tried to access something outside of what you're given. If you try to access the 11 memory, So A in 10, right? You try to access 11. This will cause stack smashing, right? You know stack smashing? You know this guy here? And you have this. You have the mustache. The eye is not that big. Oh, there's a circle. Never mind. Do you know this guy? Smashing. Alright. So you don't want to do that. You don't want to stack smash. What? So what caused the stack smash in our code, right? Is that we are trying to access data plus n, where n is the number of elements, right? So when you recall how a data is being initialized. The first value, it starts with 0, and then the last one will be n. So when we try to initialize, no, last one is not n, right? We try where last one is so you start counting from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So start. So not 0, 10 elements. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 elements. But then we start counting from 0. So 0, 1, 2, 3, blah blah blah. It will be 9. The last element will be 9. Because you start from 0. So what happens when you put data plus n, right? You are accessing data. Okay, data plus n. So your data is here. This is your data. Your n, right, is equals to 10. So when you plus 10 here, 0 plus 10, you get 10. And this is where the smashing occurs. Because this is outside what you will assign. And some compiler can detect that and say that no, you're doing something very, very illegal. So I will stop. No compile. No, I won't compile for you because you are a bad programmer. Alright? So to fix this issue, what we need to do is just we look at this data plus n, just minus 1. So when we minus 1, we will make sure that we are minus 1 will be here, right? So we're not accessing block of memory that's not assigned to us. And then when we run it, oh, that's safe. Yeah, it's good to go. And then we got one more test left. Where's the last test? Default assignment. So default assignment tests our default assignment. The default assignment tests our default assignment operator. So when we do C equals to B, that's why we use this default assignment operator. Our default assignment operator is missing. It's here. Yeah. And then sorry. Yeah, over here. And then this time we done it, so it shouldn't be a problem. This should be the problem. But since we already created it, it should be fine. Yep. And then we can run the make diff. Okay. So maybe you guys don't believe my make diff if I just do this. Or if I just do make test. You guys won't believe if I do this. So I will show you guys how I do it. This one I'll pass to you. So in our make test 2, we are supposed to run output test in. Right. Let's remove this for now, because we're not running with 3 functions, we're only running with 1. So make test. Yep. Okay. Control C. Make test 2. Yep. So there's no error, because I strip the if there's any command line, you just strip one. So I make test 2 will be error. So let's show you if there's error. It should look like this. Right. There's an error here. There should be an error here. Or I can just show it to you by changing this to show. Yep. It's the error. Yeah. Our output is here. Holy shit. Our output is here, and this is the input, and it's all wrong. Right. So let's run a makefile properly. Test in. Yep. No error. Should look like this. Clean. Okay, let's put it back. So now let's test the rest of the driver. It should be fine. Shouldn't be any error if everything is done. Since they are just different types. They're different types, but we have done our array template properly, right? It shouldn't affect anything at all. Shouldn't. So let's pray. Oh wait, I haven't done this part yet. Oops. Don't highlight everything. Alright. Nothing to be done about this. Save. Nothing to be done about this. Save. Oh, okay. Looks like we got some error. What seems to be the issue? Okay, let's not do that. Can we? Oh, this is just make. Alright. So what's causing the error? Array driver in function blah blah blah, no match for operator. So it seems that our operator function isn't running properly. Let's take a look at it. Where is our square bracket operator? Okay. So type name array t reference should be fine. Return data index shouldn't be an issue. So maybe it's not that. No match for operator. Operator types are array string and size t, aka long unsize t. It's a bit strange. Size type or size type should be correct. What do we put here? For operator, we put value type. Oh, yeah. So value type, right? If you look back at our value type is the class data type, but we need our class size type. So mistakes happen. Just switch it up. Then let's try. Oh, did it save? Didn't save. Well, maybe that's not the error. No match for operand. Operand types are basic, but in car for and size type. Yeah, should be fine. Why is it not saving? There's another arrow. Okay, okay, right. So we shouldn't just keep. Let's try to isolate the mistake. Let's say maybe string is the one that's giving us the error. So let's isolate it. Make test. Make. That's so strange. I can make, but I cannot make test. Oh, right, because there's no test to be done. Okay, maybe that's not the issue. Maybe the issue is this guy. Oops. Let's block it out. And then let's isolate the problem. Test view. Okay. So let's look. What could be the issue? Block it out. Let's run the first test. Okay. What test if in is defined but not used. Alright. Okay, it doesn't matter since we know that this works. Oh. What could be the problem? Array 0, 2. Oh, we forgot to do one thing. Forget to construct. Did we forget to do this? Let's see. Oops, don't do that. Yeah. Oh, I'm such an idiot. We changed the thing here. Sorry, it's too small to see. We changed the thing here. We changed the declaration. We forgot to change the definition. Alright. And then oops, don't do that. Do this. Alright. Seems to be working now. Let's do it. Alright. Leap of faith. Alright. Okay. I want to show you some. No, I can't show you. Okay, then let's test the string. Sorry, this is too big. Sometimes small is better. Oh no, this is a classic error. Line 50. Oh, okay. Line 50. Is it in track? Yeah. Line 50. Over here. Over here. Oh, okay. 3. Yes. Alright, everything seems to compile. Let's test. Oh. Yay, we got nothing. So we can do what we can do, right? For the make file, you just do make debug. Oh. Then you will just test this. Right? You can do make debug 3, you will do the pair, make debug 1, you will do the string. The way it works, right? It becomes main. If you call main with a number over here, like I call the executable with a number, and then you will take the number in. If it's more than 1, you will do the test based on the number. Right? So I can just make debug to do all the tests. That's fine. Make test all. There's no error. Let's do our memory check. And there's no leaks. So it's perfect. It's done. Good to go. You can submit this. Do you want? I can show you guys. I can show my sum. I can prove it. Now if I do that, then the stream will be copyright. So just take my word for it. Alright. Ah shit, I didn't record the whole time.